You might end up with a system of linear equations that looks something like this. 25x plus 400 and y equals 50x plus 200. One way to solve this system is to graph both lines and to find out where the lines intersect. Sometimes graphing can be a little challenging because it might be hard to figure out where the intersection point is, or you might be dealing with large numbers like this. So instead, you can plug the functions into your calculator and have the calculator find the intersection for you. So I've gone into my calculator and entered the first function as y1 and the second function as y2. Before I hit graph, I want to think about where these lines are going to live on the coordinate plane. If I look in the wrong place, I'm not going to see where the intersection lies. We'll notice that the y-coordinates, the y-intercepts, are going to be 400 and 200, so it might be a good idea to set our window, the y-maximum, to be larger than the biggest one, which is 400. So let's make it, I don't know, 700 over here. So if we graph this function, we get one line and then the next, and hopefully they'll intersect. Oh, and look, they do. So then you're going to hit the calc function, which is second trace. So you hit second and then trace, you're hitting calc, and then you're going to hit intersection, which is 5, and it's going to ask you for the first curve. If you hit right and left, you'll see that cursor. Curve can be a line, that's fine. You hit enter, and then it asks you for the second one, and then it asks you for the guess. So I'm going to bring this cursor decently over. You're going to have to click a few times here, that's fine, and hit enter. And the intersection is brought up on the screen. So our calculator gave us the intersection point, which we can then check by taking these two values and plugging them into both of these equations to make sure they come out to be 600 when you plug in 8 for x, which they do. This is the proper solution. So one reason you might want to graph on your calculator and find the intersection is the numbers might be really big. Another reason is the numbers might not be very nice. So for example, if we were looking at this system, if you tried to graph that, you're really not going to be able to find an exact answer because you're dealing with a decimal that goes all the way out to the hundredths. So instead, we're going to graph the function and see where the lines intersect on the calculator. So I've entered these functions as y1 and y2 on my calculator. You'll notice that the y-intercepts are 4 and -3, and the slopes are pretty tame. So if it looks like a regular type of function, a great zoom to start with is zoom 6, which is zoom standard. And it graphs the first line, and it graphs the second line, and look, the intersection point is right there. So again, second calc, which is going to bring us to 5 intersection. First curve, second curve. I hit enter after each, and then I select where I think my guess is and hit enter, and it gives me the answer. So you'll now notice that we have the answer right here, and that the answer is pretty it's not very nice. So if you ever had to round on a quiz of mine, please only go to 3 decimal places. So 1.852, comma 0.704 would be a great answer. Now you can check that answer by using your calculator and plugging this point into both to make sure it makes a true statement, which is the definition of a solution of a linear system. So let's look at one last example. We could graph both of these lines by finding the intercepts and connecting the intercepts, but you'll notice that you're probably going to have some nasty fractions. 17 is not a good sign, the 7 isn't a good sign. You can't really reduce this any further. So this would be a great candidate for graphing on your calculator and plotting the intersection. You will notice that these are not in the proper form to input into your calculator. To input a function into your calculator, the functions must be in slope-intercept form. To get these in the slope-intercept form, we must isolate y. So let's look at the first function here. 3x minus 4y is equal to 17, right here. What we're going to do is we're going to isolate y. We're going to do that by first subtracting x, so we have minus 4y equals 17 minus 3x. And then we're going to divide everything by -4. So y is equal to 17 over -4. And it's going to turn this one to be positive, but you can write it out first like this. But since you have a negative and a negative, it's going to be positive. So our final equation is going to be y is equal to 3 over 4x minus 17 over 4, because that negative carries down. So there's our first equation. Next, we're going to work on this equation right here, isolating y. So first we subtract 6x, so we end up with negative 6x plus 7, divide by 2, negative 3x plus 7/2. So now we have our two equations in slope-intercept form. The next step is to input these into our calculator. I've now input these functions into my calculator. You'll notice that I've put parentheses around all of the fractions. Parentheses around all of the fractions. You can see the 17 over 2 if I go up and to the right. I put parentheses around everything because you will need them most of the time. Sometimes you can get away without them, but sometimes you can make some pretty bad mistakes. So I've entered these with lots of parentheses. And I'm not quite sure what this is going to look like, so I'm going to start with zoom standard, which is zoom 6. First line, graphs below. And our second line, oh, look at that, it's nice. The intersection point does show up on our graph. So then we hit second trace, which is second calc. We do intersect, which is 5. First curve, I'm going to hit enter. It already jumped to the second curve. And the reason it's asking is you could have more than 2 graphs on here. You could have more than 2 lines. Hit enter, and now it's asking me for the guess. So I'm going to go over to the guess right about there and hit enter. And it gives me an intersection. So our answer to this would be the point. The solution would be 2.067 comma negative 2.7. You could check that by throwing it into your original equations. So the important things to keep in mind are equations must be in slope-intercept form to enter them into their calculator, which means you need to isolate y. Finding the proper window when you're graphing can be tricky. Sometimes you're zoomed in too far, sometimes you're zoomed in too close. You need to sometimes take a little while and some careful thought to find the proper window to see where the 2 lines are intersecting. And last, round your decimals to 3 places. If you do that, you're going to be exact enough for this class and also for AP Calculus.